All right, a final example of the dramatic impacts of small population size on allele frequencies is known as the bottleneck effect. So, a population bottleneck occurs when there is a sharp reduction in the size of the population, a massive mortality event. Usually, it's due to some sort of catastrophe, such as an earthquake, a flood, fires, famine, disease. But whatever the cause, most of the original population, with all of its genetic diversity, so this represents the population, the different colors of the marbles represent different alleles. We can see most of the individuals do not survive. So we're talking, 90% mortality. The handful of survivors that do make it through the bottleneck, when they numerically rebound, or if they numerically rebound, even though the population abundance or population size has grown large, if you look, there has been a major loss of genetic diversity. The diversity of alleles, as represented by the colored marbles, is now greatly reduced. And genetic diversity is going to remain low. It's only going to increase when gene flow from another population occurs, or very slowly over time as random mutations occur. This new population, which is now genetically homogeneous, it's less robust in its ability to adapt to and survive in a changing environment. It has less genetic raw materials from which to draw from to cope with some new virus or a rapidly changing climate. Cheetahs are the textbook example of the bottleneck effect. So, at the end of the last ice age, the Pleistocene, about 10,000 years ago, cheetahs almost blinked out. They almost went extinct. Today, even though they have numerically rebounded, cheetahs have very low genetic variability. You may know that genetic differences among humans means that when we have an organ transplant from one person to another, we have to take intense immune system suppressing drugs to keep the recipient from rejecting the organ, from attacking it, even if it's from a parent or a sibling. But with cheetahs, they are so genetically homogeneous, so genetically similar because of this bottleneck effect, that you can take a skin graft from a cheetah here in southern Africa, and you can graft it to another cheetah as far away as the Middle East in Iran, and you won't see an immune response. Why? Because cheetahs are so genetically similar to one another. And although Homo sapiens, humans, do have higher genetic diversity than cheetahs, we are still 99.9% genetically identical. Why? So, we also went through a massive bottleneck. So, demographers think that our population could have gotten as low as about 10,000 individuals. And it corresponds with this massive volcanic eruption, this Toba super eruption that occurs about 74,000 years ago on the island of Sumatra in Indonesia. It's probably the largest explosive volcanic event of the Quaternary period, and it's believed to have caused a significant impact on global climate. And it may have even influenced human migration patterns out of Africa at that time. But around the same time as this super volcano goes off, human beings get down to just about 10,000 individuals. So we almost went extinct. And now here we have the end of the Pleistocene, right? And we're entering into the Holocene here, and so this is the domestication of sheep and goats and agriculture. The plow was invented, and Homo sapiens have increased exponentially there since. But even though we've numerically rebounded from 75,000 years ago, we're 99.9% genetically identical because of the human bottleneck.